Amount of substance. Amount of substance measured using mole. Mole, very large number of particles. Avogadro's constant, 1 mole contains 6.02 times by 10 to the power 23 particles. Number of particles equals number of moles times by Avogadro's constant. This is really important because very underrated formula that's not probably talked about a lot. Obviously, you got moles, mass over amount, moles, constant, volume. This one's really important as well. Number of particles, number of moles times by Avogadro's constant. Avogadro's constant. 1 mole of any substance has a mass the same as mR in grams. Concentration of solution is how many moles are dissolved per 1 dm cubed, 1 liter of solution. Number of moles, concentration, moles per dm minus cube times by volume. Dm cubed, 1 dm cubed equals 1000 centimeters cubed. What does that ideal gas equation let you find out? The number of moles in a certain volume of gas. We just need to know temperature and pressure. The gas is at the number of moles in a certain volume of gas. What centimeters cubed is 1 times by 10 to the power minus 6 meters cubed. 1 dm cubed is 1 times by 10 to the power 3 meters cubed. To convert from degree Celsius to Kelvin, Kelvin equals degree Celsius per 273. Ionic equation for any reaction involving ions that happen in solution. Only the reacting particles and the products they form are included in the ionic equation. We leave anything that isn't ion in the solution as it is. We just leave it. We don't cancel out. We just leave it. Spectator ion, any ion that's present in a reaction mixture but doesn't get involved in the reaction, is spectator ion. Any ion that's present in a reaction mixture but does not get involved in a reaction. Using an ideal gas equation to work out how much gas a reaction will produce. Sodium reacts with excess water. Because of that excess water part, we know all the sodium reacts. So, yeah. Ideal gas equation to work out how much gas a reaction will produce so we can use large enough apparatus. Empirical formula is the simplest whole number ratio of atoms of each element in a compound. Molecular formula is the actual number of atoms of each element in a compound. Molecular formula made up of a whole number of empirical units. Theoretical yield, the mass of products that should be formed in a chemical reaction, and it assumes no chemicals are lost in the process. State 2 reasons: actual mass product, actual yield always less than theoretical yield. Not all the starting materials react fully. Some chemicals are always lost. For example, some solution gets left on filter paper, lost during transfers between containers. Percentage yield tells you how wasteful a process is based on how much product lost during the process. State one thing percentage yield does not measure. It does not measure how wasteful the reaction is. Reaction with 100% yield can still be wasteful if lots of atoms from reactants wind up in byproducts rather than desired product. Atom economy, a measure of the proportion of reactant atoms that become part of desired products rather than byproducts in balanced chemical equation. A measure of the proportion of reactant atoms that become part of desired product rather than byproducts in balanced chemical equations. State 3 advantages of processes with high atom economies. Better for environment, produces less waste, plus any waste that's made needs to be disposed of safely, therefore less waste made, therefore the better. Because less waste made, so less waste needs to be disposed of safely. More efficient use of raw materials, more sustainable, uses up natural sources more slowly. Less expensive, less spent on separating desired product from waste product, and less on treating waste.